Good afternoon to everyone. So please write this problem. Evaluate integral 0 to infinity x power m minus 1 divided by 1 plus x power n whole power p into dx. And first we need to evaluate this integral. And then using the result of this integral, we need to deduce the value of this integral. Okay, that is given. The value of this integral is given here, and hence you need to show that integration from 0 to infinity dx by 1 plus x power 4 equal to pi by 2 root 2. Solution. Instead of so first I am going to consider the integral I is equal to integral 0 to infinity x power m minus 1 by 1 plus x power n whole power p into dx. Okay. So here I am going to take one by x power n. Okay, wow. Here okay, one by x power n is equal to some t. So put t equal to 1 by 1 plus x power n. From this, find x in terms of t or x power n in terms of t. Just cross multiply. 1 plus x power n is equal to 1 by t. So this implies x power n equal to 1 by t minus 1, or okay, 1 by t minus 1. Okay, you can keep like this. Okay, now if you differentiate with respect to x, n into x power n minus 1 into dx is equal to minus 1 by t square into dt. Okay. Now, what about the limits? When x is equal to 0, when x is equal to 0, t is 1 by 1 plus 0. So t equal to 1. When x is equal to infinity, when x is infinity, 1 by infinity, so 0. So t is 0. So our integral I is t equal to 1 to 0. The integrand. What is the integrand? X. Okay, well. So actually x is equal to, you can write this is 1 minus t by t. Okay, x power n. So from this x is equal to 1 minus t by t whole power 1 by n. Okay. So now I need what? X power m minus 1. Earlier I told that x is equal to what? 1 minus t by t whole power 1 by n. So 1 minus t divided by t whole power 1 by n. But here power is m minus 1. So m minus 1 divided by n. Okay. So next, 1 by 1 plus x power n. So this is actually 1 by 1, this is t. So t power p, t power p into dx. What is the dx? So from this, you should write dx is equal to minus 1 by n minus 1 by n divided by t square, 1 by t square. Okay, and then here x power n minus 1 is the denominator. But I told that x is equal to what? 1 minus t. From this, x is equal to 1 minus t by t whole power 1 by m. So x power n minus 1 is equal to 1 minus t by t whole power n minus 1 by n. So, okay, into 1 by 1 minus t by t, this is a t, 1 minus t divided by t whole power n minus 1 by n. So this is actually what? This is dt. Okay, this is where is dx. Okay, dx. This is dx. Okay. Now when I am going to simplify further, so this is equal to, because of this minus, I can interchange the limits. 1 by n is constant. 1 by n.
Sir,
Yes.
you should have the right last dt, sir.
Sorry, Purnachandra. dt. Yeah. Okay.
Yes.
Yeah, dt. Yeah, I missed dt. Yes. Okay. So dx is equal to, oh yeah, including everything. Okay. So this is actually dx is equal to minus 1 by n into 1 by t square into this term into dt is equal to dx. Okay. And then here, yes, I told already for this minus, you need to interchange the limits. So from t equal to 0 to 1. Okay. Now, what is 1 minus t whole power m by n minus 1 by n t power p, and then t power minus 2. I'm writing everything in the numerator. And then t power n minus 1 by n, this t power. Okay, this is going to the numerator. And then 1 minus t whole power minus of n minus 1 by n into dt. Okay. So now this is equal to 1 by n, t equal to 0 to 1, 1 minus t whole power m by n minus 1 by n, and then here 1 minus t whole power minus n by n is minus 1 plus 1 by n, and then t power p minus 2, n by n is 1 minus 1 by n. Okay. And then I missed what? Anything else missed here? Yes, I missed here. This t power, the denominator we have what? T power m minus 1 by n is going to the numerator. I think I missed that part. I will write here. So 1 minus t whole power m minus 1 by n into t power minus m minus 1 by n. Okay. So still you have what? Here this minus m by n minus n by n plus 1 by n into dt. So this is equal to 1 by n integral t equal to 0 to 1. So minus 1 by n plus 1 by n gets cancelled. T power p minus m by n minus 2 plus 1 minus 1 into 1 minus t whole power m by n minus 1. Minus 1 by n plus 1 by n gets cancelled. So now what is the value of this integral? Anyone?
Beta of m comma n comma p minus n comma n.
Udavan, please tell beta of
M by n comma p minus m by n.
Yes, m by n comma p minus m by n. Very good. Okay, so first we will write, okay, both are it satisfies the symmetry property. Okay, beta of m comma n equal to beta of n comma m. So very good. Udavan, beta of p minus m by n by m by n. So now what is the left hand side? Actually, what is I? I is equal to, please tell, 0 to infinity x power
M minus 1
divided by
1 plus x power n whole power p.
Plus x power n whole power p.
Yes, sir.
Whole power p. Okay, into dx. Okay. So this is equal to 1 by n. So use the relationship between beta and gamma function. So this is the gamma of p minus m by n into gamma of m by n divided by, just add these two, gamma of p. So this is the first part. You call this is 1. Okay. So now look at the second part. What I need to substitute in equation 1 to get the second part? Anyone?
Equals 1, sir.
P is equal to 1, sir.
P equal to 1. Very good, Uddhavan and Purnachandra. If we substitute P equal to 1, x power m minus 1 divided by 1 plus x power n into dx. So this is equal to 1 by n. So 1 minus m by n in gamma of m by n. This is gamma of 1. Okay, gamma of 1 is 1. Okay, there is no need to write again. So now how to simplify the next step? Is there is any result I gave like in this form?
Pi by n sin.
Okay, வெற்றி திரும்பம் correct, but left hand side தான் சொல்லு. Left hand side என்ன?
1 minus x. Gamma of 1 minus x into gamma of x.
Gamma of 1 minus x into
Gamma of x.
Gamma of x.
Gamma of x. Very good. This is equal to this is equal to what? Correct. வெற்றி திரும்ப நீ சொன்னதுதான்.
Pi by n sin pi.
pi by sin
n pi.
என்ன எக்ஸ் வந்தா என்ன வரும்? இங்க
h by
எக்ஸ்
h by.
அப்ப இங்க இங்க நம்ம என்ன n யூஸ் பண்ணோமா?
இல்ல சார்,
எக்ஸ் தான் யூஸ் பண்ணோமா? ஓகே, எக்ஸ் பை. So I think already I gave this result. Is it correct? Okay. So using this result, instead of x, I have m by n. So 1 by n into pi by sine x is equal to m by n into pi. So this is, I think, the second result. Okay. You can write 1 by sine theta is cosecant theta. So you can write this is equal to 1 by n. 1 by n. You can write pi by n, no problem. Cosecant m pi by n. The left hand side is what? Integral 0 to infinity x power m minus 1 by 1 plus x power n into dx. We call this is 2. So to get the third result, what I need to substitute in equation 2?
m is equal to 1.
M is equal to 1, n is equal to 4.
n is equal to
Very good. Yeah. It's correct, Purnachandra and Vititruvan. Because the numerator is, so you have just a dx. So I need to make it, this is 1. So m should be 1. And here you have 4. So n equal to 4. 0 to infinity dx divided by 1 plus x power 4. This is pi by 4. Cosecant m is 1, so pi by 4. So this is pi by 4. You know sine pi by 4 is 1 by root 2. So this is actually root 2. So final answer is pi by 2 root 2. Okay. So please write this problem. Problem is, please write. Okay, so please write this problem. Evaluate a triple integral over v dx dy dz, where v is the finite region of space. So that is the tetrahedron formed by the planes x is equal to 0, y is equal to 0, z equal to 0, and the plane equation is given 2x plus 3y plus 4z equal to 12. So this is A, B, C. Okay, well, actually you can see the tetrahedron here. And also draw the diagram. So in this problem, we need to evaluate the triple integral over dx dy dz. Okay, so either you can calculate, you can the order is you can either write dx dy dz or dz dy dx. Okay, but here I am going to take first integrate with respect to z. So the innermost integration is z. So actually z is varying in this line peak. The limits for z, okay, the limits for z, the variable of the innermost integral are 0 to z1. Okay, it is 0 because the xy plane, it is the point x comma y comma 0. So this part, the point Q is on the tetrahedron. So that's why it is x comma y comma z1. Okay. So where x comma y comma z1 lies on the plane 2x plus 3y plus 4z equal to 12. So instead of you know that this point is x comma y comma z1, so and hence it satisfies this equation. So 2x plus 3y plus 4z1 equal to 12. From this 4z1 equal to 12 minus 2x minus 3y. So z1 equal to 1 by 4 into 12 minus 2x minus 3y. So that is z1 here. Okay. So after performing the innermost integral, the remaining is the resulting integral is the double integral. Okay, the resulting double integral is evaluated over orthogonal projection. Okay, orthogonal projection of the plane A, B, C. Okay, I am going to project the plane ABC on the xy plane, that is over the triangular region OAB. Okay, OAB in the xy plane as shown in the figure, the next slide. If you project, you will get OAB. So only this portion. OAB. Okay, again I'll repeat. So after performing the innermost integration, the resulting double integral is evaluated over the orthogonal projection of the plane. The plane is what? A, B, C. You are projecting the either you can project on xy plane, or you can project on YZ plane, or you can project on XZ plane. Okay, here we are projecting the whole the plane ABC in the xy plane. So if you project, you will get only this portion, that is the OAB. So in OAB, okay, suppose here Z is 0. Z0 means 2x plus 3y equal to 12. Okay, wow. So this is the line. This is the line AB. Okay, wow. This line AB is what? Because Z equal to 0. So 2x plus 3y equal to 12. So this is the 2x plus 3y equal to 12. If you divide by 12, you will get what? X by 6 plus y by 4 equal to 1. So this is how the form x by a plus y by b equal to 1. This point is A. A is when y is 0, x is 6 comma 0. This point is when x is 0, this is 0 comma 4. This is the origin, 0 comma 0. Okay. Now next take a strip, because next dy. Okay, next after dx, next you have dy. So dy means I need to take a strip parallel to y-axis. Here y is what? 0. Here what is y? 3y equal to 12 minus 2x. So y equal to 1 by 3 into 12 minus 2x. So that is given here. In the double integral, the limits for y are, y varies from 0 to 1 by 3 into 12 minus 2x. Okay, once you take the strip parallel to y-axis, and then you should move the strip like this. First, initially it is here, and then here, here. So x varies from where to where? 0 to 6. So x is from 0 to 6. So the remaining thing is just calculation. Okay. So I is equal to integral. So first x is equal to 0 to 6 and y equal to what? Y equal to 0 to 1 by 3 into 12 minus 2x, and next z equal to 0 to 1 by 4 into 12 minus 2x minus 3. One by 4 into 12 minus 2x minus 3y. What is the integrand? The integrand is dz dy dx. Okay. So now integrate first with respect to z. X is equal to 0 to 6. Y equal to 0 to 1 by 3 into 12 minus 2x. So dz, so just z, limit is from z equal to 0 to 1 by 4 into 12 minus 2x minus 3y into dy into dx. Substitute the upper limit. Zero to 6, y equal to 0 to 1 by 3 into 12 minus 2x. If you substitute the upper limit, we have 1 by 4 into 12 minus 2x minus 3y into dy into dx. So take 1 by 4 commonly and integrate with respect to y. Integration x is equal to 0 to 6, 12y minus 2xy minus 3y square by 2 minus 3y square by 2. The limit is 0 to 1 by 3 into 12 minus 2x into dx. So now apply the limits. So okay, 1 by 4, x is equal to 0 to 6. I think here 12, you are substituting what? Y, yeah. Okay, 12 minus 2x is common. Okay, for y I am going to substitute what? 12 minus 2x by 3. Okay, upper limit is over. Minus, still we have here minus 3 by 2, 12 minus 2x whole square. Lower limit is everything 0 into dx. Okay, so this is also 12 minus 2x whole square, 1 by 4, x is equal to 0 to 6.
Yeah.
Yes,
3 into 1 by 3 is 1 by 3 into 12 minus 2x whole square, sir.
Here 3 by 2, okay, by 9,
By 9, sir.
Yes. Thank you, Pumachandra, by 9, because here I have 3. Yes. So this is actually what? 12 minus 2x whole square by 3 minus 12 minus 2x whole square by 3 by 18, so 6 into dx. So take 6 is LCM. So if you take 6 is LCM, 1 by 24, 0 to 6, 6 LCM, what is, this is 2 times 12 minus 2x whole square minus 12 minus 2x whole square. Okay. Okay, is correct. Into dx. So next step I will write. This is 1 by 24. 0 to 6. This is 12 minus 2x whole square. Into dx. So I think here 2 is common. So if you take 2 common, 2 square is 4. 4 by 24. Integration 0 to 6. 6 minus x whole square into dx. So this is 1 by 6. If you integrate this, you'll get a 6 minus x whole cube divided by 3 into, if you differentiate minus x, you'll get minus 1. The limit is from 0 to 6. So now this is minus 1 by 18. Upper limit is 6 minus 6 is 0. Minus lower limit is for x is equal to 0. So 6 power 3. Okay, 6 power 3. So this is 216 by 18, that is 12. Okay. So similar to this problem, the next problem is also very similar idea. Okay. Just write the problem and draw this diagram. Evaluate triple integral over v dz dy dx divided by root of 1 minus x square minus y square minus z square, where capital V is the region of space bounded by coordinate planes, and the sphere x square plus y square plus z square equal to 1, and contained in the positive octant. So first I will tell what is a positive octant. So in the note it is given. In 2 dimension, the x and y axis divide the whole xy plane into 4 quadrants. That is, the quadrant containing the positive x and the positive y are called positive quadrant. That is the first quadrant. Similarly, in 3 dimension, the xy, yz and zx plane divide the entire space into 8 parts, so called octants. Okay, each one is octant. The octant containing the positive x, y and z axis is called the positive octant. So here here V is what? Region of space bounded by the coordinate plane and the sphere that is contained in the positive octant. So please draw this diagram. Instead of the sphere, in the previous problem, you have what? Tetrahedron. So first, you should find the limits for Z. So here Z varies from 0 to Z1. 0 to Z1. So this point Q is lies on the sphere x square plus y square plus z square equal to 1, and hence Q satisfies this equation. So that means x square plus y square plus z1 square equal to 1. From this, z1 square is what? Z1 square equal to 1 minus x square minus y square. So I need z1. Z1 equal to plus or minus, but we are in the positive quadrant. So that's why it is root of 1 minus x square minus y square. So that is here. Z1 equal to root of 1 minus x square minus y square. So we found the limits for the innermost integral z. Okay, ba? So z varies from 0 to root of 1 minus x square minus y square. Okay, now you should tell. I think in the previous problem we projected the same idea here also. Okay, so here we project what? The plane ABC on the xy plane. Okay, if you project, you will get what? Only this portion. Similarly, project the sphere, okay, in the xy plane. Okay, you will get some region. So draw the region and find out the limits for y and x. Do it.
Sir, for y is it root of 1 minus x square, sir?
Yeah, y yes, 0 to root of 1 minus x square. Is it correct, Uttaman?
Yes, sir.
What about x? Yes, correct, Uttaman. What about x? 0 to
1.
Yeah, 0 to 1 is correct. Okay. So if you project the sphere, only you will get this portion. Okay, wow. Only you will get this portion. Okay, so actually this is nothing but what? Part of a circle. Okay, wow. A circle in the, because here z equal to 0, so x square plus y square equal to 1. Okay, so there's a portion of a circle. Okay, that is, you can see here. After performing the innermost integration, the resulting double integration is evaluated over the orthogonal projection of the spherical surface on the xy plane, that is over the circular region lying in the positive quadrant. Circular region lying in the, this is a positive quadrant as shown in this figure. So here next I should take a strip parallel to y-axis. So here y is 0, here y is what? Root of 1 minus x square, and this is the point. A is 1 comma 0, because this is x square plus y square equal to 1. This is the origin. So x varies from 0 to 1. So I think now we found the limits. Now the remaining part is what? Calculation. Okay. So try and get the answer. If you got the answer, I'll give 5 minutes time maximum. Okay. Do it and find out the answer and post in the group. Type in. I will write slowly. I is equal to x is equal to 0 to 1, y equal to 0 to root of 1 minus x square, and z varies from 0 to root of 1 minus x square minus y square. Into integrand is what? dz dy dx divided by root of 1
Sir,
minus,
dx.
sorry,
Sir, மேலே dz போட்டிருக்கீங்க sir, dx.
dz dy dx. Yes, thank you. 1 minus x square minus y square minus z square. Okay. So now, so any idea next how to proceed the next step?
Sir, 1 minus x square minus y square is equal to t square.
Okay, that is take some a square. Okay, wow. Okay, so dz by root of a square minus z square. I think you have the formula. What is the dx by root of a square minus x square? Integration dz by, okay, wow, dz by root of a square minus z square is equal to what?
One by a into sin inverse of z by a, sir.
1 by a into 1 by, whether 1 by a will come?
A by 2, 1 by 2a.
No. I'm asking sin inverse of x by a will come. I know that. But Purna Chandra is told to be 1 by a is also it told to me. That's why I'm asking. So I think it is a sin inverse of x by a. Purna Chandra?
Yes, sir. Sin inverse of x by a, yes, sir.
Yeah. Okay. But z by a here. Okay. Because here you choose the z. So it is z by a. So now, next step. So consider this is actually what? A square. I is equal to integral what? 0 to 1, 0 to 1, x varies from, and y varies from 0 to root of 1 minus x square. Okay, if you integrate this one, you'll get sin inverse of z by a. What is a?
1 minus x square minus y square.
Is it correct? Yeah, correct. Should be root of, okay? Root of 1 minus x square minus y square. Because a square equal to what? Here, a square equal to 1 minus x square minus y square. So a equal to root of 1 minus x square minus y square. And the limit is from 0 to root of 1 minus x square minus y square. Okay. Suppose, if you substitute the upper limit, you'll get sine inverse of 1 minus sine inverse of 0 into dx. Here, sorry, dy dx, dy dx, dy dx. So this is actually pi by 2, this is 0. So pi by 2 is constant. So I will write pi by 2 here. Okay, now limit, integration 0 to 1. Integration y equal to 0 to root of 1 minus x square into dy dx. So now integrate with respect to y. Integrate with respect to y. We'll get pi by 2. Integral x is equal to 0 to 1. Y limit equal to y equal to 0 to root of 1 minus x square into dx. Pi by 2, x is equal to 0 to 1. Upper limit is root of 1 minus x square. Lower limit is 0 dx. So what is the result I need to apply here? Integration root of a square minus x square dx is equal to what? X by 2 root of a square minus x square plus a square by 2 into sine inverse of x by a. So I think these results you studied in the +1 or +2 level. So again, if you don't know this result, okay, well, this result, even you can start you cannot write you can write only the first step. Okay, well, even you cannot proceed the second step. Okay, now if you don't know this result, hereafter you cannot proceed. So first you should know these results. So please refer your +1 or +2 book, or you can check in the internet. Google search பண்ணாலே கிடைச்சிடும். Integration formula கொடுத்தீனாலே you'll get all the formulas and you can write in your notebook. Okay, so now it is available in the Veerarajan book. Okay, so only thing you need to search it. Pi by 2 x by 2 into root of 1 minus x square plus a is 1 by 2 sine inverse of x. Limit is x is equal to 0 to 1. So this is equal to pi by 2. If you substitute the upper limit, you will get 0 plus 1 by 2 into sine inverse of 1. Sine inverse of 1 is what? Pi by 2. So upper limit is over minus lower limit is 0 plus 0. So this is pi square by 8. Okay. So before going to the next problem, actually this is comes under evaluation of triple integral using beta and gamma function. So already we discussed evaluation of double integral using beta and gamma function. So remaining, you have only two topics. So this is this one and then application. Okay, so nearly I am going to come to the end of the fourth unit and the end of the syllabus. So maximum I need 3 to 4 classes. Before Saturday I will finish. I think I will finish it. Evaluation of triple integral using beta and gamma function. Okay, so write the problem. Find the value of triple integral. Find the value of triple integral x power L minus 1, y power m minus 1, z power n minus 1 into 1 minus x minus y, 1 minus x minus y minus z whole power p minus 1 into dx dy dz taken over the interior of the tetrahedron bounded by x is equal to 0, y equal to 0, z equal to 0 and x plus y plus z equal to 1 in terms of gamma function. Okay, so here what is the given integral? I will take I is equal to, so I think you know the diagram for tetrahedron. Okay, I will draw it again. So this is 1 comma 0 comma 0. This is also 0 comma 1 comma 0 because x plus y plus z equal to 1, 0 comma 0 comma 1. Okay, so please tell the limits for first z and then y and then x. So can you tell what is z varies from where to where?
0 to 1 minus y minus x.
0 to 1 minus y minus x. X minus, okay. In the order, okay, x minus y. Okay, correct. Uddavan. What about y?
0 to 1 minus x.
First, you need to project in the xy plane. So if you project, you will get only this portion. X, y, you only get what? Only this portion. Okay, so we call this is A, this is B, this is C, this is the origin. So we'll get O, A, B. This is x plus y equal to 1. This is 1 comma 0. This is 0 comma 1. So it should take a strip parallel to y axis. Here y is 0, 0 to 1 minus x. Okay, and then x varies from 0 to
0
1.
to 1.
Yes, the integrand is x power L minus 1. Okay, y power m minus 1, z power n minus 1 into 1 minus x minus y. Okay, I don't have the space. I will write here 1 minus x minus y minus z whole power p minus 1 into dz dy dx. So please wait a minute. Okay. So now put the charger. Okay, now if you integrate with respect to so now if you integrate with respect to z, x and y are constant. So I is equal to integral 0 to 1 x power L minus 1 I will write here, and this is x. Y varies from 0 to 1 minus x, and then I will write y power m minus 1 here. Okay, and then z varies from 0 to 1 minus x minus y. Okay, z power n minus 1 into 1 minus x minus y, okay, minus z whole power what? P minus 1, whole power p minus 1. Here dx I will write, here dy, here dz. Okay, so now what is the value of this integral?
1 minus x minus y power n plus p minus 1.
N plus p minus 1 into what?
Beta of n comma p.
Very good. So that is the result we discussed in the previous class. Okay, va? So what is the result? Please tell once again that result. I will write here. Integral
1 minus
0 to 1 minus y. 1 minus x. So please just tell, because if I write then
Sir, 0 to 1 a, sir.
0 to a. Okay,
Yes,
0
sir.
to a.
Y power
M minus 1.
m minus 1 into a minus y whole power n minus 1 dy.
A power
M
m
plus
plus n
n
minus 1.
minus 1
ah,
beta of
m comma
m.
n. Yes, correct. Teacher Mohan Purnachandra. So instead of a here, here we have what? 1 minus x minus y. Okay, va? So here instead of a, here we have 1 minus x minus y. Okay. So that is x is equal to 0 to 1 x power L minus 1 into dx, y equal to 0 to 1 minus x, y power m minus 1 into dy. Instead of a, you can write what? 1 minus x minus y whole power m, whole power not m, n, here n, plus p minus 1 into beta of n comma p. Okay. So beta of n comma p is constant. Remaining is x is equal to 0 to 1 x power L minus 1 dx, y equal to 0 to 1 minus x into y power m minus 1 into 1 minus x minus y whole power n plus p minus 1 into du. So again, this integral is equal to what? Integral that is equal to beta of n comma p integral x is equal to 0 to 1. Okay, x power L minus 1 into dx. So what is this integral? Again, use this idea. So a equal to 1 minus x. So 1 minus x
minus 6 whole power m plus n plus p minus 1.
m plus n plus p, yeah,
Minus 1.
yeah, minus 1. N plus p minus 1 into beta of what?
M comma n plus p.
Yeah, m comma n plus p into dx is already I wrote here. So beta of n comma p is constant, and then beta of m comma n plus p is also constant. Remaining have 0 to 1 x power L minus 1 into 1 minus x m plus n plus p minus 1 into dx. Okay, so now this is equal to beta of n comma p into beta of m comma n plus p. What is this?
Sir, beta of L comma
Yeah, please tell Purnachandra. Beta of
L comma m plus n plus p.
L comma n plus n plus pr. Yeah,
Yes,
this is the definition of beta function. Okay, so that's okay. Now you can use the relationship between beta and the gamma function. Gamma of m into gamma of p by gamma of n plus p, and then gamma of m gamma of n plus p by gamma of m plus n plus p gamma of L into gamma of m plus n plus p by gamma of L plus m plus n plus p. You can cancel gamma of n plus p, gamma of n plus p, and gamma of m plus n plus p you can cancel. Okay, so remaining is what? Remaining is gamma of m, okay, L m n p. You can write in the order is equal to gamma of L, gamma of m, gamma of n, gamma of p divided by, so I think only you have this. Gamma of L plus M plus N plus P. So this is the final answer. Okay. So last column. Okay.
Sir, can you show the previous slide, sir?
Okay.
Thank you, sir.
Okay. Show that the volume of the region of space bounded by the coordinate planes and the surface root of x by a plus root of y by b plus root of z by c is equal to 1 is ABC by 90. Okay. Actually, similar type of problems we solved in the double integration. So actually, yes, the double integration, find the area of the asteroid. Okay, x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. And to find the area of the ellipse, x square by a square plus y square by b square equal to 1. So I think we used for those problems substitution method. Okay, so we converted the original region into in the form of x plus y equal to 1, capital X plus capital Y equal to 1. So then only you can easily apply beta function. Okay, because your limit is from 0 to 1, you can easily get it. Okay, same idea here also. I am going to apply the same idea. Here, instead of x plus y equal to 1, here I am going to convert it into x plus y plus z equal to 1, like a tetrahedron. Okay, so I think you got the idea now. So we should take, this is capital X, this is capital Y, this is capital Z. So then you'll get capital X plus capital Y plus capital Z equal to 1. And then the limits for Z is what? The limits for Z is what? Z varies from 0 to
1 minus root y by b minus root x by a.
I told that x plus y plus z equal to 1. Okay. So z varies from 0 to
1 minus y minus x.
Yeah, 1 minus x minus y. Okay, after the projection, y varies from where to where?
1 minus x.
Y varies from 0 to 1 minus x. And then x varies from where to where?
0 to 1.
0 to 1. That's all. Okay. So this is the idea. Okay. Solution. So the volume is equal to volume of the region. Okay, or region of space. Okay, is triple integral over V dx dy dz or dz dy dx, where V is the region of space which is given. Capital V is the region of space given in the problem. Okay. So now I am going to substitute root of x by a equal to capital X, and then root of y by b equal to capital Y, root of z by c equal to capital Z. So from this x by a equal to x square, x is equal to ax square, dx is equal to 2ax into dx. Similarly, dy equal to 2by into dy, and dz equal to 2c z into dz. So the remaining thing you can fill up. So I got it dx dy dz. Okay. So now your v, okay, volume. Volume equal to triple integral over, originally it is v, now I will put v dash. So v is in the, you know that it is in the, here the given region of space means x greater than or equal to 0, y greater than or equal to 0, z small z, everything is greater than or equal to 0, and root of x by y plus root of y by b plus root of z by c less than or equal to 1. So that is the region of space V. But here the region of space is capital X greater than or equal to 0, capital Y greater than or equal to 0, capital Z greater than or equal to 0, and capital X plus capital Y plus capital Z less than or equal to 1. So this is the region of space here. So triple integral over V dash dx dy dz. Okay, if you multiply everything, 8 abc 8 abc into d z xyz xyz into dz dy dx, where b dash is the region of space in xyz space defined by capital X greater than or equal to 0, capital Y greater than or equal to 0, capital Z greater than or equal to 0, and capital X plus Y plus Z less than or equal to 1. So that means a tetrahedron like this. Okay. A, B, C, this is origin. So this is 1 comma 0 comma 0, this is 0 comma 1 comma 0, this is 0 comma 0 comma 1. Okay. So now volume V, I will write just V. I think you told that 8 ABC, 8 ABC is constant. Okay, integral capital X varies from 0 to 1. Okay, x into dx, and capital Y varies from where to where? 0 to 1 minus y into y dy, and then capital Z varies from 0 to 1 minus x minus y into z dz. So first, usually we don't write x and y. First we wrote z only first. Okay, what is z here in the xy plane? It is 0. On the tetrahedron, it is z equal to, because this is x plus y plus z equal to 1, so z equal to 1 minus x minus y. So after the projection in the xy plane, you will get, this is x plus y equal to 1. So if you take a strip parallel to y axis, so y varies from 0 to 1 minus x. So that, sorry, 1 minus x. I wrote here 1 minus y. And finally, x varies from 0 to 1. Okay, 0 to 1. So now if you integrate, what you will get? 8 ABC, x varies from 0 to 1, x dx, y varies from 0 to 1 minus x, y dy. If you integrate this, z square by 2, z square by 2, limit is from, z varies from 0 to 1 minus x minus y. So 1 by 2 is constant. So 4abc, x varies from 0 to 1, x dx, y varies from 0 to 1 minus x, y dy. Upper limit is, okay, dy will write little next. This is 1 minus x minus y whole square into dy. Okay, what is this? 4 ABC integral x is equal to 0 to 1, x into, so please tell, this is what? 1 minus x whole power 1 plus,
2 plus 2
okay,
minus
this is actually 2 minus 1.
yes, sir.
Yeah,
2 plus 3, sir.
2 plus 3 minus 1.
Minus 1.
Yes. Beta of 2 comma 3 into dx. Okay. So beta of 2 comma 3 is constant. Beta of 2 comma 3 is a constant. So 4 ABC beta of 2 comma 3 integral 0 to 1 x into 1 minus x whole power 4, 4 into dx. So this is equal to 4abc beta of 2 comma 3. Okay, using the definition of beta function, this is beta of 2 comma 5. So 4abc, this is gamma of 2, gamma of 3 by gamma of 5. This is gamma of 2, gamma of 5, gamma of 7. So 4 ABC, this is gamma of, this is 2 is 1 factorial. So 1 into, this is a 2 factorial. So 2 by 4 factorial, 24, okay, into, this is 1 into 24 by 6 factorial is 720. So 24 gets cancelled. So this is 8 ABC (720), or this is 9 times, so ABC by 90. So this is the final answer. So I think here these types of, still we have 2 more problems related to this type. Okay, wow. So the related to this type means a triple integral using beta and gamma function. So I will do this problem tomorrow. Okay, but I have the duty, okay, exam duty tomorrow from 3 to 5. Okay, I should be there 2:30. Okay, so is it possible to you can come at 1:30? I will take 1:30 to 2:30. I am ready to take. What about you? But I am taking only 2 problems. Only 2. Okay, a maximum I will finish it half an hour or 45 minutes. Yes or no?
Yes, sir.
Okay, that's why I'm
Yes,
asking.
sir.
Okay, thank you. Okay, so 1:30, I think I know that up to 1 o'clock you have class. Okay, I think half an hour is enough for lunch. 1:30 to 2:15, maximum I'll take 2:15, or I can't take beyond 2:30 because I need to be there at 2:30. Okay, thank you. And one more thing I want to tell, only few students are here. Okay, I will tell. And also I'll tell the next class also. I think everybody is a very good student here. Okay. Okay. So I think you know that the examination is offline. Okay, offline. So if it is online, sorry.